So, what I want to talk to you about today is various toxic substances that can damage DNA through different mechanisms, which lead to mutations, cancer, and other health issues. Here are some of the well known DNA damaging substances and explanations of their harmful effects. The first that we're going to look at is ionizing radiation. This includes X rays, gamma rays, and radioactive substances. Sorry, everyone, it's not going to turn you into a green Hulk. Ionizing radiation can break DNA strands and ultimately cause mutations. The mechanism is that ionizing radiation can create free radicals, which are highly reactive molecules that can directly damage the DNA backbone and their bases, leading to strand breaks and base modifications, which are not for the better. Certain chemicals like benzene, found in cigarette smoke, industrial emissions, and some solvents. The mechanism is that benzene metabolites can form DNA adducts, which are chemical compounds that bind directly to DNA, causing structural changes and interfering with DNA replication. Look out for DNA adducts to come in other substances we're going to discuss later on. It comes up a lot. Formaldehyde. I remember we used to have these, like when we dissect a cat or fetal pig, and these things would be preserved in formaldehyde, used in various industrial processes and found in cigarette smoke. So I think we're getting a theme here. Cigarettes, tobacco, probably not good for you. Mechanism. Formaldehyde forms cross-links between DNA strands, which can inhibit DNA replication as well as DNA transcription, and which ultimately will lead to mutations. Polycyclic aromatic hydrocarbons, PAHs, present in tobacco smoke, grilled foods, as well as in air pollution. The mechanism is that PAHs are metabolized into reactive compounds that form DNA adducts, there it goes again, causing mutations and cancer. So stay away from that. Heavy metals. We got arsenic, found in contaminated water, industrial processes, and some pesticides. And I think in some of the older spirits, wines, things like that, arsenic sometimes is in that too. And some rice. Mechanism. Arsenic interferes with DNA repair mechanisms and generates oxidative stress, leading to, ultimately, DNA damage. Mm-mm, not for me. Cadmium. Present in cigarette smoke, industrial emissions, and some foods. Mechanism. Cadmium can cause oxidative DNA damage and inhibit DNA repair enzymes, leading to an accumulation of DNA damage. Moral of the story, when you're a kid, don't suck on nickel cadmium. Tobacco smoke. Nitrosamines. Found in tobacco smoke and some processed foods. The mechanism is that nitrosamines are metabolically activated to form DNA adducts. There they go again, which can lead to ultimate mutations as well as cancer. Acetaldehyde. This is a metabolite of alcohol and a component of tobacco smoke. So, smoking and drinking at the same time, probably not a good idea. Mechanism. Acetaldehyde forms DNA adducts and crosslinks, which interfere with DNA replication as well as DNA repair. UV radiation. We talked about ionizing radiation earlier. Now we're talking about UV radiation. UVB and UVC radiation. Some of that comes from the sun, and some comes from artificial sources like tanning beds. UV radiation causes the formation of thymine dimers, where two adjacent thymine bases bond together, distorting the DNA structure and blocking replication and transcription. So if you're going to be out in the sun, use some protection. I'm not saying don't go outdoors. It's great to go outdoors. Great to go in the grass, barefoot. Have the sun shining on your face, but just not too much of it. Okay. Viruses. Human papillovirus (HPV), which is a sexually transmitted virus that has been linked to cervical cancer and other cancers. Its mechanism is that HPV integrates its DNA into the host genome, disrupting normal cell function and ultimately promoting uncontrolled cell growth. Certain pharmaceuticals. Chemotherapy drugs, right? Chemotherapy drugs. I mean, you're thinking here of the These drugs are supposed to help you to get rid of cancer, but it can cause other problems, such as cyclophosphamide and cisplatin. The mechanism is that these drugs form cross links between DNA strands or directly damage the DNA structure, which would then inhibit cancer cell replication but can also affect normal cells. So, in other words, it's a side effect, right? You're getting rid of cancer, but then you're damaging your normal cells as well, which is why it's real brutal. Alcohol. We have ethanol, which is a compound that's consumed in alcoholic beverages. The mechanism is that ethanol is metabolized to acetaldehyde, which you discussed earlier, which can form DNA adducts, which comes up again and again, and generate reactive oxygen species, leading to oxidative DNA damage. Why is DNA damage as a whole harmful? Why should you be worried about it? The first is it leads to a lot of mutations. DNA damage can lead to mutations, which are changes in the DNA sequence. Mutations can disrupt normal cell function, potentially leading to cancer and other genetic diseases. Then there's cancer itself. Many DNA damaging agents are carcinogens. They cause changes and can lead to uncontrolled cell growth and tumor formation, and that's one thing you don't want is uncontrolled cell growth. Trust me on that one. Genetic disorders. This is damage to germ cells, sperm, or eggs, and can lead to inherited genetic disorders in the offspring. Cell death. Severe DNA damage can trigger cell death, which is apoptosis, which can contribute to tissue damage as well as organ dysfunction. Understanding and mitigating exposure to these toxic substances is crucial for maintaining genomic integrity as well as overall health. I hope you found this very brief rundown on substances that can damage your DNA helpful. Please continue to like, share, and subscribe. I love you and appreciate you all, and have a great day. Bye.